Hello, and welcome to IoT Builders, a live stream where we discuss a range of topics on the Internet of Things, from embedded devices to cloud services, all from an IoT Builder perspective. Let's see, this is episode 8 of our live stream, and today we have Axel Großklaus joining us to talk about the things part of IoT. My name is Dan Gross. I'm a senior developer advocate for FreeRTOS and AWS IoT. And today I am joined by my co-host, Nenad Ilic. Hi, Nenad.
Hi, everybody. Yeah, I'm Nenad Ilic. I'm also a senior developer advocate around AWS IoT.
Awesome.
Happy to be here, as always.
Excellent. So, as I mentioned, we have Axel joining us to have a discussion around the things part of the Internet of Things. Let's see. Are you on the line, Axel?
Yeah, I'm here actually. Hi, Dan. Hi, Nenad.
Hello, and welcome. Where are you joining us from?
From Hamburg in Germany.
Fantastic. That's excellent. All right. Hey, why don't you maybe introduce yourself, and we can get into the discussion after that.
Yes, thank you. Yeah, I've been building IoT systems since quite a long time. Actually, I started sometime in the 90s when it wasn't called IoT, of course. I started out in system administration, later on IT security, and throughout all this time, I built all these systems that somehow autonomously worked on the network. Which later became IoT. And I've worked in many areas where that were always very safety or security critical, like aviation or medical devices, payment. I'm now in, and so it was always to have IoT systems that are quite complex, but that also just have to work and have to be reliable. I founded a number of companies myself. Two of them were actually product companies. One does media security for USB sticks, for example, or for mobile media as an appliance system. And the second one does autonomous disinfection system. So in those both companies, they're both still operational. I had a lot of time actually making a lot of mistakes. Trying to get things to work and trying to get a startup off the ground. But maybe the third company I founded is the most interesting. This is a service company that specialized on doing electronics engineering and always the things with a big T of the Internet of Things, especially for startups or for corporate innovation hubs. So in that part of work, I've done this for over 10 years now. I have a lot of time. Having to watch others make all kinds of mistakes when building devices and trying to get everything to work. So yeah, a lot of stories have been piling up through this time.
Yeah, so you mentioned mistakes. I guess some of the best ways to learn are through making mistakes. Maybe you could share some of the mistakes that you've made and maybe some of the learning experiences that you've had along the way.
Yeah, sure. Mistakes is kind of natural. It's simply when you do innovation, everything is moving so rapidly. It's all new technology that simply nobody really knows about. And you try to use these things and combine them and build bigger systems. And of course, not everything works as you expected. So it's only natural to make mistakes. But it's also what's behind. Like the industry has this saying, hardware is hard, and then everybody chuckles and I don't know, does something else. But there's really a lot behind this on why hardware is hard, especially in an innovation context. Innovation is driven a lot by how startups work, and the startup culture is formed by how software startup works. And a lot of these things don't just work for hardware.
Yeah, and so the hardware part of IoT, the things part, is what makes some of these projects challenging, and how to navigate some of these projects is often what what maybe leads startups into trouble, or projects to get into trouble as well.
Yeah, well, looking back, I would say when you're having a hardware startup, you actually build not just one thing, which is your product, but you actually build 4 things at once. The first one is, of course, the product. This is what startups mean when they say they want product market fit, so the actual value to the user, to the customer. Second, you build your technology, your device, all these components and how this interacts, and lots of code and cables and other things. But you build even more. You build always a process. When you have something that you can touch, it's not the technical design is always for a certain number of units that you'll be making. For if you're making just 10 or 100, this is completely different than for 100,000 or 1 million devices. And if you have a design for one area or order of magnitude, it will not work for the other. And
that's very different than software. Software, maybe scales a bit differently, right?
Yeah, exactly. Yeah, scaling is also important for software, but for hardware, for software, since you can just copy it, the process of manufacturing is not really there for software.
Yeah.
No, but the fourth thing you're actually building is your team, your processes, and the ability to build things. Again, in software, you usually have programmers. People even say they have full stack developers, so they can do everything at once. And for hardware, you will always have like electronic specialist, mechanic specialist, software, of course, compliance, lots of other things. And this cannot be done by one person. It's simply too much. It's too much complexity and it's too much work. And so for startups, it's always a challenge to actually mature the team and find out what to make or buy, and how to combine all these pieces.
Yeah, interesting thing you said is like for bytes. I mean, copying bytes is easy, right? But copying, a piece that is in like real world is multiplying it is hard, right? So that's kind of the issue that most of people are thinking of, like, okay, let's copy the software, let's copy the data, and everything is fine, and we can have it in multiple copies. But with this, it's kind of like you have to figure out the process that you need to in order to produce multiple copies of that device. And then I think interesting thing that sparks into my mind was, like, we talked about this before, is those iteration cycles. Like, we think about sprints, like 2-week sprint, 1-week sprint, where you make a feature and then it's there and then it's usable and it's in production and all that stuff. But then when you talk about like designing a PCB or even doing a enclosure manufacturing, like those iteration cycles are measured in like months, right? And you need to think about that as well when you're designing hardware, right?
Well, you can have an agile approach to it. There's for example, there's design thinking where it says, okay, quickly iterate over prototypes and figure out what you actually want to build. And this actually, to a point, works for physical devices as well. Downside one is it's extremely expensive. I mean, you can do a PCB spin in 2 weeks, in 4 weeks. This is no problem if you're willing to pay for it.
Yes.
But it's extremely expensive. You will need a big team and a lot of automation. But you can do this. One other problem with hardware is, as soon as you have something that's where compliance comes in, because people may get hurt or so, then you can't do testing that easily. Of course, you can test it in a lab, but a device that can hurt people, you cannot give it to users. You cannot do a small pilot and install it everywhere and then see it if it works, or if people get electrocuted. So this
well, and even for certification purposes too, devices need to be close to the final
to the
design.
final product.
exactly.
Yeah, so even to get Wi-Fi or some of these other certifications, it is a march to the final design, right?
Well, you could actually get away with changing it a little. I mean, the compliance system is very, well, software people would say waterfally. So yeah, you usually you do your testing on the final device and then sell it. But what if you look at what manufacturers do after the first release? Of course, you can change it. And then there's a bunch of paperwork that you do internally, documenting every change and telling yourself, okay, this is still safe. So you could probably have some agile, like kind of abuse this and take your first prototype, put it to the lab, have the certification done, and then finish the rest, do some paperwork and go on. So this would be basically a startup style to do something. But you're right. Usually it's the test lab, and it sends you a nice bill of 50,000 euros. And 4 months later, you have a sheet of paper that specifies that you're compliant.
Yeah, a lot goes into that. I just wanted to touch on something you said, just a minute ago around full stack development. Does that sound funny sometimes? Having being versed in both the hardware and the software part of IoT, because I think a lot of full stack, or the notion of a full stack developer, is still all really software is, and so. Do you have a term for somebody who's really full stack, including hardware design and things like that?
Yeah, it depends on how low you actually want to go, and if you want to do your own ASIC. There's more similarity actually than it looks on the outside. Again, if you do embedded, you have firmware and you have like simple digital electronics. It's like a microcontroller, a couple of sensors, nothing too scary. And you can have people who can do the full stack of doing like a regular PCB with a microcontroller, the firmware, networking on top of that. But as soon as you have specialized area, higher bit rates, radio frequency designs, ASICs, FPGAs, all these kinds of things, then you need specialists. But this is the same in software. A full stack developer, of course, they can do your back end and like a random database and a bit of web design and and they can build you a full site. However, in software, it's again, if you're looking at big sites, you need specialists and for scalability, for accessibility of websites, for whatever these things. So for random run-of-the-mill things, you probably have these full stack people in both areas.
You just reminded me of a project I did back in 2011, 2012. It was like, I was definitely doing full stack in a sense of was programming the microcontroller, or designing the PCB, soldering everything, programming the microcontroller. We had a board with an SoC. I think it was IMX6. So I had to do the BSP, program the user space in Linux, and then do the things like the backend and the front end. And then I also had to do the enclosure, because my original study was mechanical engineering. So I did the enclosure of the product and the sensor design as well, and all that kind of stuff.
Yeah.
And it was like, it was really fulfilling to see everything working out in the whole stack, but it was so tiring and it was so much details that I had to kind of shortcut in order to make this work. So and the time frame was like insane. So that's something that you would need a team to work on.
Yeah,
Really
the time frame is a good point. Often for an embedded system, it's simply too much work. It's not like if you have a few really good people, maybe they can do everything, but they can't do all these month and month of work with a small team.
Exactly.
Yeah, multimeter to web server logs. Yeah, that would be that would be tough. It's like the super stack or something like that.
Yeah. And I think just before we go into this, I think the word I was looking for this was marginal cost. So when you said about the replication, so in software, like the marginal cost is like 0, right? So you have the change in cost is small, and then you have the change in quantity is 0. So technically the marginal cost is 0. But when you have hardware, then change in quantity, it's something meaningful, right?
Yeah, and that you mentioned cost is really there are so many pitfalls in hardware design where the cost structure is really so much different than in software. You have a lot of costs that you simply don't have for software. Then everything is a lot, like for example, compliance. For software, you can just launch it. You don't need a test lab to do all kinds of elaborate testing. But also changes are so extremely costly. And for an app, if something breaks, you can just do a next release in the App Store and replace it everything. If you do an IoT product that is already shipped out to customers, especially for B2B customers, you may actually have to pay to fix this, to like send out a technician and somebody traveling around the country, if only it's like flashing software upgrades. In the worst case, you actually have to do mechanical changes. And so one little bit, or what, like the smallest defect in a product can actually bankrupt the whole system or like completely break the whole product. I once had it where there was one small resistor that was like 20% too large or too small or something in a design, but it was 100% that this resistor would burn out after a few months. It was just a calculation error, and this was an onboard unit for a vehicle actually, and this was a few hundred units. And they had to bring the whole fleet in, remove these boxes, ship them to me. We changed the resistors, and they shipped everything back out. And I had insurance, so the insurance paid this, but the damage was like 5 times the overall worth of the contract of what we were doing, just because one small calculation error for a resistor.
So would you chalk that up to? Oh, sorry. Go ahead, Nenad.
No, go on.
Oh, I was going to say, would you chalk that up to one of your mistakes or learning experiences?
It definitely was a mistake, and it's what's to be learned from this is you will never be perfect. So prepare for failure. Have insurance. Have plan Bs. Have things like that, because these small errors. They will happen, and they will keep happening. They happen in software all the time, and then it's just like ticket, commit, push to production. 10 minutes later, you can have coffee. And people are not perfect, especially in an innovation environment, in the startup environment where there's chaos and people are doing things they have never done before. So it's more prepare for failure than rather prevent failure. Prevent failure is not possible.
Yeah. I was about to ask, were you able, I mean, this is not possible to fix by software, so the resistor thing. So there's no other way than just to kind of like physically figure out the logistics and then physically do it, right?
Yeah.
So yeah. I think we also talked briefly about the, like you said, hardware is hard, and I remember you were saying once, like, you compare it with an instrument, right? Maybe you can talk about that. I really like that analogy.
Yeah. This is a metaphor from myself. I've kind of done through the years. Hardware is hard, and it's simply like every non-trivial task. Consider like you want to learn an instrument. And nobody would expect that you can just pick up the instrument, maybe have read a book on how to play, I don't know, the piano, and then play and do this perfectly. And it's the same with every skill in life, that it's not completely simple. You cannot just learn it from theory. You have to practice, and you have to do it a few times over. And a lot of this is going to be failure, and it's going to be really hard learning an instrument. But you will probably ask yourself, why am I doing this? On the other hand, people do this because they love music. They love playing instruments. And this is a lot of, I feel, the same for a lot of people in the IoT and the hardware industry. I think that there's probably two ways to feel about hardware. You can either hate it or you can love and hate it. And the sooner you come to terms with that reality, that this is always going to be there, like practice for an instrument, it becomes a lot easier, actually.
Yeah, that's a great analogy. So software has certain constraints, obviously, and but hardware has those constraints, plus more, right? I think we've talked about things like BOM costs or certain certifications or things like that. So what's a IoT startup or a hardware startup to do in this environment? It seems like an awfully daunting challenge.
Yeah, well, in the on the higher level, for everything you do, looking at the back or at the 4 different things I mentioned that you're building, always know what you're actually building. Is it the device? Is it a process? And keep everything in mind, and because there are different principles apply there. Then don't make your tasks too big. You're still learning. And keep in mind what you can do, what your team can do, what your roadmap allows. And for startups, yes, there are probably a lot of features in the investor presentation, in the pitch, that you put in there because the investor wanted to hear some fancy buzzwords like I don't know, blockchain and AI and whatnot. But in the end, everybody just cares about shipped units. So build what you actually need, and nobody else is going to want these features basically back then anyway. So don't overdo it. On the more practical side, design your hardware for changeability. For a lot of features, there's a way, or there's usually a possibility to do this with discrete components or in a microcontroller. And classic electrical engineering is very, very fixed on having specific solutions, and possibly even doing it with discrete components. The more you put in a microcontroller, or would rather say, put something in a microcontroller and make the microcontroller a bit bigger than you may actually need it. Because everything that's part of the software in the microcontroller suddenly becomes changeable. If it's changeable, it's fixable. And if it's fixable, you can better react to all the bugs that you're going to have in there. And this is kind of a cultural difference between innovation and startup people and coming from a software background and the electronics industry that always wants to have everything very specific and cost reduced to the last cent.
Yeah, and this is kind of a change, really, where instead of having a fixed design that goes out to the field, and the only way to really change it is to send somebody out or send it back or something like that. But now, with a lot of IoT devices, companies are relying on OTA processes, for example, to update software, not only for fixes, but even for features or for other kinds of improvements maybe that they've discovered the product needs. But this is although this is happening quite regularly, it's still kind of a newer concept, I think, for a lot of product designers, right?
Yeah, well, OTA that you mentioned is a very good example for a normal IoT product, I would probably start with the update functionality first, without implementing anything else. Like bring up the operating system, and the first thing that you want to have is remote updates, and optimally directly integrated with your continuous integration chain. You can just push daily releases towards it. And this is also something where IoT has really grown. IoT has mainly grown within the last 10 years, not so much in the concepts of how devices are actually using internet, but actually having a platform for all these everyday tasks that 10 years back, everybody was doing their own homebrew, either doing their own homebrew protocols, or where they were just adapting existing web technologies and doing HTTP requests that were extremely heavy to backends, and this didn't work at all. And the industry spent around 10 years. Now we have MQTT, and we have good messaging, and we have a few standard protocols. OTA works kind of well, often comes from the MCU vendor. And there is a lot of technology now that actually works. Now Docker is coming, and Edge Docker, and all kinds of apps on the edge. Whether or not you like Docker is a different question, but it's a lot of technological growing up, that you have a good working environment, and you don't have to spend so much time integrating or building all these services yourself. In a way, it's like the personal computer started around 1980, and it spent the first 15 years of, well, somehow getting to work, that you had an interface that would work, and you have acceptable performance and whatever. And then it really took off. And I feel it's similar with IoT. Now we have a good technological platform, and now let's see what we can build. And for the next 10 years, I actually hope that there will be more on the conceptual side of IoT, so that it's not just like sending sensor data to some backend because you have to do it, but there's actually interesting things going on, what the devices do with each other.
Yeah, and I think. So, what do you think about things like modules or other ways to encapsulate functionality rather than discrete? You mentioned discrete components, but these days there's a lot of modules. But I think there's maybe two schools of thought on that modules can add additional expense in some cases. That discrete components don't, but there's probably a trade-off at some point. It depends on the number of devices you're shipping.
You mean physical modules, like pieces you plug together?
Yeah, physical modules. But where I was going with it is, it seems like not only services, not only hardware, but software and services are also kind of modularizing in a way where you don't need to reinvent the wheel on some of these things.
For software, definitely, and there's a lot of. I mean, every library on an embedded Linux system is a module. For software, we do a lot of this. There's always, every now and then, people try to do this for microcontrollers, actually pushing object files down. In theory, this could work. In practical, it's too fragile and too complex, actually. But there are other things like having higher level languages, even in microcontrollers, that are interpreted, where you also have a more abstract or more standardized runtime environment where you could have this. And if this works, and I think we'll see the technology improve, this would also be very, very useful, because then again, microcontroller software is always very dependent on the specific IC. And ST alone makes 3,000 microcontrollers. So there's a lot of complexity there. But if you have a higher level language that you can push down to implement some sensoric or some business logic, that's great. For hardware, people again always try to have modularized hardware designs.
Right.
And they often try to fix a problem that's simply not there. The only reason you would have a modular design would be to replace in the field after the product has been sold. So this would be either to do component repair, which is great for sustainability reasons, but for consumer hardware is often simply not done, or to upgrade it. Everything else, if you want to do modular electronics, a lot of functionality is done. It can be done in the ECAD software, where you have like pre-routed areas or other types of maybe solder-on modules or so. But modularized hardware, it's a horror for reliability of the hardware. Connectors are extremely expensive, and in the end, nobody's going to use them anyway.
Yeah. You mentioned higher level languages. This is something that I find pretty interesting, because we're seeing some things like MicroPython and Rust get some attention. Do you think this has legs? Do you think for production devices this is going somewhere?
For very specific use cases, I think yes. For if you just want, for example, you want to push down a specific calculation of filter to pre-process sensor data. So for these very specific plug-in modules that you already have in your overall architecture, I think this could work great. And Mark, who you had on the previous episode, he's currently trying to sell me WebAssembler on the edge.
Yes. WebAssembly. Oh yeah.
And this is a really,
that's very interesting. That is very interesting concept.
And I think this could go somewhere. I'm looking at this with great interest. If it would still be kind of a heavyweight virtual machine that you have there, and you would. I don't know how feasible this is to actually have on a microcontroller, but for an embedded Linux system, as a first step, this could be really quite interesting.
I can tell you, I've actually seen some prototypes on a microcontroller that seem rather promising. But
there is also a big thing now. I think companies called Fermion. We met on the open source summit, and they are talking about having like Kubernetes is now quite spread around, but it also adds a lot of complexity. And then you have the containerization of all the applications and so forth.
Yeah.
And they're advocating like once you're already developing those applications, you can just have them compile for the WebAssembly, and then they're building some tooling with like Nomad and some other applications that actually can use WebAssembly directly. So you don't need that separation and all that stuff. So you can just execute those in WebAssembly. So that also is kind of interesting as well. I mean, let's see what's happening. But I really like this.
One downside I would actually see is, again, unfortunately, compliance. Because as soon as you allow any meaningful change to what your product does, it's probably going to affect IT security and IT safety and safety. All the certifications that a product has, and there are so many more coming up, both for safety of consumer devices as well as IoT cybersecurity. Of course, all these certifications would suddenly be void, and this is hard to deal with, especially safety. If you don't really allow low-level code like binary code and the untrusted code from somewhere else cannot really do most of it. It's still going to be a problem, not as bad. But yeah, as the certification requirements grow and grow and grow, this is an additional obstacle that you would have deploying this technology to actually have it to be legal to sell it.
I see. Yeah. You've mentioned that you've had a experience in quite a number of fields that require compliance, like aviation and medical and payment systems and things like that. Yeah, maybe talk a little bit about what some of the maybe pitfalls or traps are with compliance and ways to navigate that successfully.
Well, for payment, what I'm currently working on, there's actually a trend of to do this to allow this kind of third-party apps on payment terminals, and this is what companies want to do, and we're talking to certification authorities. What you could actually like there's PCI certification in the back. They do the security of these payment terminals. And you kind of can get this right. And I don't know if it's a plus, but they say as long as you put in the user manual, tell the user, please don't do this. Please don't write insecure software and put it on your payment terminal. Then you'll be fine. Because the other thing about certification is often, or it's financial liability. So who is at fault? And a lot in product safety is just pushed off to the user, whoever, or just put in the manual. So don't do this; you will hurt yourself, or bad things will happen.
Yeah, what's interesting about that is, I guess if it's a kiosk, is there a user manual?
No, but the well, of course, there's a user manual for the owner, and only only they would allow third-party software on there.
Yeah,
but with all these systems now that well, AI is slowly entering all these embedded devices, and people want to do data collection and run neural networks on there to do real-time analysis of whatever usage data and so on. And of course, there's this motivation to allow like sensor processing apps onto it, and allow, especially have your generic component that does something to do industry-specific algorithms directly on there, and nobody really can or wants to pay for recertification everything you change something.
Right.
So the well, for certification as a whole, I've good news and bad news. Bad news is certification for safety really hurts, especially if you have a device that can actually hurt people. For example, in the consumer goods like kitchen appliances and things like that, there's a lot more compliance coming up, and it's a lot of work. It's extremely complex. However, it only really hurts the first time. Like many things in technology, everything is kind of similar. And once you have figured out the process of CE compliance, of FCC compliance, of all these other things in the back, if you do it a second and a third time, it won't hurt so much. And there we are circling back to the beginning. You really just have to practice this, and the second and third time, it'll be a lot easier. So don't give up, basically.
Yeah, and you mentioned how in one of our discussions about how development, changes in some ways because of compliance. It's hard to just tack that on the end. And I think the example you gave was this UV light product that. It's even hard to develop, because in order to even develop with it, you have to have some level of compliance, because it's a harmful product, right?
Well, specifically for the UV panel, since it was sometimes you're lucky when something is extremely innovative, it's not really that regulated that much already. So for classic things like motors or robots or whatever, this is technology that's been around for decades, and there's very well established standards that you have to follow. For UV safety, this was, of course, you have to do regular product security, but you don't get into what's called functional safety. Functional safety is what the industry or the industrial sector uses for things that can really hurt people. And There's also something new for founders that go into the area. For specific kinds of functional safety, you're simply not allowed to write that software. You have to go through company certification first. This is a multi-step, usually starts with ISO 9001, and then you go on to the actual other things. Medical sector is the same, and getting your company to actually like certified to these standards can take 2 to 3 years, and again, it's extremely it costs a lot of money. So like founders get in there and they have this really great idea of to build something, and it doesn't matter how good the product is. It doesn't. You simply can't get the product certified because the company is not certified, and this is kind of strange. But yeah, I can see why it's there, but it's extremely frustrating because it shuts off a whole sector from direct innovation. You can just work with partners who have done this for quite a long time, but also they also usually don't want new players on the market. And well, there's this tendency of the big players, of course, to keep startups out.
Yeah. Yeah, I recall one of the partners in the free RTOS space, Wittenstein. They have a safety certification flavor of free RTOS known as Safe RTOS, for example. Right, this is one of those examples where that can be used in safety certification for certain products and things like that. Yeah.
But there is so much more process. It's not just the components. It's the way software is done. It's extremely formal. And if people are complaining about waterfall development, they haven't seen nothing yet. This is like at that level, it's like writing 5 lines of code and spending another hour doing review and justification and paperwork and testing. So this is kind of the exaggerate a bit, but there's an extreme bureaucracy down to the developer systems, to the developer tools. Nobody's allowed to touch anything, and everything needs to be documented.
Yeah, so hardware is hard and compliance is hard. There's a lot of challenges in the IoT space. What are some bright areas that we see, in innovation? What things are helping this whole process? I think we mentioned OTA and modular designs, and we mentioned. Things like higher level languages perhaps helping.
Yeah, there's so much more reliable technology now that is, and everything is a lot cheaper as well. But it's like the working environment in IoT has changed in a way that system administration has changed from like 90s, like lugging around Unix servers and screwing them into a rack to, well, now I can have my Kubernetes set up and just run everything. So IoT,
that's a good point.
IoT has changed so much, and you can do so much more, and you have to worry about the reliability a lot less. But again, everybody tends to grow. Like the more tools you have, the bigger your dreams grow of what you can actually do. And this is one of the cool things just when we're doing IoT. You get to play with all these great new technologies and materials and concepts and everything. It's a whole world of leading edge technology out there, even though as a startup, often you're not allowed to have it, but at least you can play around with it.
Yeah, you brought up a good point. Even on the cloud side, we had a few episodes ago, we had Ed Miller from ARM on to talk about ARM virtual hardware in the cloud, which was quite interesting because you can model your ARM hardware now in the cloud without the without the actual hardware. And so that can be a help in developing
Well,
IoT solutions.
The technology is actually an absolutely great first step. At the moment, since it's basically just ARM and they offer the IP core or the processor cores, it's mostly useful for people who design microcontrollers or software for these microcontrollers, like compilers. Because for a full microcontroller, you're missing all the interfaces. But assume other companies like NXP or ST who are building, they are just buying all the building blocks, like the IP cores for all the interfaces and so. They just license these in anyway. And once we have the technology to go from the IP core description, be it FPGA languages or just to the ASICs, and simulate this in a software environment, and assume a microcontroller manufacturer actually allow this, and you could just start up a specific microcontroller without having to buy the development board and say, okay, now I want 100 and I want a network and I want a simulated LTE modem. This could be an amazing development tool for prototyping IoT systems and do continuous integration and do large scale testing. But it's a long way to go from there. But if for it, you would have to do this for the microcontroller and also for a lot of the sensors.
Yeah. I think there's this notion of virtual interfaces that they have, but yeah, I think it'd be really great to model, say, a fleet of devices and push those out before you actually ship before you actually ship products. Right?
If you have a certified emulation of a sensor, this would be an extremely great tool to write software faster and more reliable.
Yeah, fantastic. Yeah. Let's see. My colleague Nenad had to drop off. He had a prior engagement, so he's no longer on the line. I did want to open it up to. I think we have a few listeners here. If you have any questions for Axel, feel free to jump in. I think on Twitter Spaces here you can raise a flag and I can make you a speaker. If you don't, that's fine too. We'll keep talking, but I figured I'd open that up. So what else? What else is happening that's cool, Axel?
Oh, what's happening that's cool? I've focused so much on all the problems. What's on the well? It seems like slowly the supply chain crisis is easing up. And slowly there are a number of fun new microcontrollers on the horizon, like the next generation of ARM V8 microcontrollers is slowly coming. So this is something I'm personally looking forward to a lot. What I also find very interesting is Zephyr OS, which is, well, bluntly put, is probably Yocto for microcontrollers. So this is something that probably has to grow a few years, but could finally achieve some unification of the development platform that manufacturers have not really been able to achieve up to this point. So again, we're seeing also on the infrastructure level, like FreeRTOS, as you mentioned, Amazon is putting a lot of work and developing new subsystems into that technology, and the overall spirit of open source and availability is coming into. So the microcontroller industry is kind of opening up. And for hobbyists and smaller companies and startups, everything suddenly becomes a lot more accessible. And you can slowly feel like everything in electronics is happening slowly, but you can slowly feel a cultural shift actually taking place. And this is done in an incremental fashion. And this is the only way, actually, I think that you can change embedded development. Every now and then you hear people talk about, we'll fix embedded development by this new language or this new toolkit or this and that. And everybody wants to replace C. And this is usually people who are not really working in embedded. simply because I don't think there's any way to, with an installed basis of devices and of technology and of people and everything, but you can't really replace anything. You can't start from scratch. Software people always want to do rewrites, and then they start, and after 1/3 of the time the budget runs out, and then you have after a few years you have 3 half-done rewrites. So this doesn't work, and it will never work in, for, well, quotes, serious embedded. I would bet my left leg that will still have new C development in 100 years. However, at least the overall technology and the culture is changing and adopting things that work from open source, and that's great to see.
Yeah, maybe that gap between what we call makers or hobbyists and professional hardware designs, maybe that gap is closing. I think we've seen some big differences between those communities, but maybe there's some progress there.
Yeah, maybe, do you know the Gartner hype cycle? The Gartner hype cycle, probably, right? Where the curve goes up and then crashes. And now that you mentioned the maker movement, this is a lot what I feel happened, that the maker movement really took off in 2012, 2014, something like that. And there was this first run of IoT startups with stars in their eyes and running around making all these great products, and everybody went bankrupt. And then for the from like 2016 to 20 or so, everything crashed and no venture capital wanted to touch hardware products in any way, because everything, like the bubble kind of burst on a technological way. And now I think we're through that valley. And now we have, I think it's called the plateau of realistic expectations in the Gartner hype cycle. And now we see, okay, maybe we should just focus on building nice new infrastructure layers, one at a time, and see what we can actually improve, rather than, like, hardware is very evolutional, not really revolutional.
Yeah, that's true. So I think, let's see. So to kind of wrap things up a little bit on the theme, I think when teams embark on this journey in IoT and hardware, I think one of the points you've made is to really focus on realistic goals. Maybe you could talk a little bit about that as kind of an end of the of this thought.
Yeah, I think it's great to dream big and to make ambitious goals, but don't just have a path where you actually have to do all these features and have to match all these goals. So it's kind of a lighthouse on the horizon that you're steering towards, not a marching plan that you just have to get to the oasis in the desert. Otherwise, you'll die of thirst. So yeah, be really in the moment, what you're doing, what your team is doing, looking at the skills, and not so much the formal skills, but actually the experience that they had. And if nobody in your team, like if you have a lot of electronics enthusiasts, that's great, and they have built hardware like circuits already, that's also great, and maybe they have already done a PCB. And look at that. And this is not so much about knowledge about electronics, but actually having went through this. And if you have somebody who set up manufacturing and went through compliance, these are the boring parts, but these are the crucial parts. So have a good reflection on what you can, like how much experience you have yourself, what your team has, and for the next step, how much risk is involved. Is it something that I know I have to do, but I've never done, and I am working wholly on assumptions? Or is it just, yes, I know it's going to be hard, but I have done it a few times before, and I know what's coming. So
yeah.
yeah, but then
Yeah, I
just
like that.
you want to go
Yeah.
up a mountain, just one foot before the other, and see where it takes you. And look, yeah, the moment is usually more important than the long-term goal.
Okay. Yeah. Yeah, I like that. That's really good. Well, we are just approaching the top of the hour here, so unfortunately we're out of time. It's been a great conversation,
Thank you.
Axel. Really appreciate you taking the time today. So thank you very much.
Oh, thank you. I'll be back for a lot of the other episodes. I really like the podcast.
Okay, fantastic. Well, that's great to hear. Yeah, if you'd like to hear more, we're back again next week. We're doing this IoT Builders weekly,
Yeah.
and so join us again next week. And until then, so long.
Thank you. Have a great day.
All right, you too. Bye-bye.
Bye.